Hello! So this is just all about setting up story problems that end up being a quadratic equation. We already saw one of these in the last video with the projectile height equation, which you will definitely see sometime, but moving on. Okay, so nothing new theory-wise here. Let's just do some story problems. The length of a rectangular room is 1 foot less than twice the width, and the area is 45 square feet. Find the dimensions. Okay, so what am I about to say? I am about to say, draw a picture. So let's draw a rectangle. Beautiful. All right, the length is 1 foot less than twice the width. So generally we call this the width. Let's call it W. If you want to call it X, if that makes you feel better, go for it. And 1 foot less than twice the width means 1 less than 2W. So 2W minus 1. And we've seen problems like this, but we haven't dealt with area yet because it involves a quadratic. So the area of a rectangle is just one side times the other side, so it's going to be W times 2W minus 1. All right, and that picture is about to go away, so make sure you get that picture down before I move on now. All right, and we've got that the area is 45. Okay, and from here, you'll see that it's a quadratic that we have to factor, but it's pretty straightforward. So you know what to do. Multiply everything out, get everything on one side in standard form with 0 on the other side. 2W squared minus W equals 45. Subtract 45. 2W squared minus W minus 45 equals 0. Okay, I think this would probably actually be a good one to do with grouping. So let's do it that way. So remember, with grouping, we need A times C. And 2 times negative 45 is negative 90. So now we need that. It's just negative W in the middle. And remember, that really corresponds with like a negative 1W. So we need 2 factors of negative 90 that add to negative 1. So think about it. What that means is we need 2 factors of 90 that are 1 apart. That should make it pretty obvious, right? Got to be 9 and 10. And to be more particular, we need it to be negative 10 and plus 9. So split up this W like that. So split it up like 2W squared minus 10W plus 9W minus 45. And now use grouping. So factor something out of these first 2 terms. The most you can factor out is 2W. And then factor something out of these 2 terms. The most you can factor out is 9. Notice we got a W minus 5 left over in both cases, so the grouping worked. So it's 2W plus 9 times W minus 5, which means we got 2 solutions, and then you'll see what happens with our 2 solutions. So, I'm going to kind of go faster through this part because we've done this a million times. This one tells us that W is 5, which makes perfect sense. This one tells us that W is going to be negative 9 halves. Subtract the 9, divide by 2, or negative 4.5. And then you just ask yourself, does that make any sense? It does not. So in the context, and that'll happen with these, in the context of this equation, it completely makes sense to have 2 solutions. In fact, we usually do. But in the context of the dimensions of a room, it doesn't make any sense for these to be negative. And we've seen that before. When we get negative answers in here, the negative one just doesn't make any sense and we can toss it out. Okay, so the answer is 5. And then again, look at the original setup. We were asked for the dimensions plural with a Z. So let's see, if the width is 1, the length is 1 less than twice that. So 1 less than twice 5 is 9. And then it does make sense that 5 times 9 is 45 feet. Okay, so, we probably could have guessed the numbers 9 and 5, but that doesn't count because I need to see the work. So it's 9 feet by 5 feet. Or we're going to do one that involves a very old formula for mathematics that you've probably seen before. We've talked about triangle geometry a bit, but let me just throw some definitions at you. A right triangle is any triangle that contains a a right angle or a 90-degree angle, you know what that looks like. Look at any corner of the room you're sitting in, that's a 90-degree angle. So that's right angle. We indicate the right angle with, that's a right triangle. The right angle has that little box there. And we have some names of stuff. So this side, we use lowercase letters for sides. This side is called the hypotenuse, kind of a nerdy word, but you probably know that. And then I don't know if you remember what the other two sides are called. Other two sides are the legs. So there's two legs and a hypotenuse. And then we have a very old formula all the way back to our boys in ancient Greece, relating these three sides of a right triangle. All right, and I should say, the numbers A, B, and C represent the lengths. So if I said something like A equals 5, that would mean that the side of this, the length of this leg, or the length of this side of the triangle is 5 feet. So you know where I'm going with this, right? All right, so our good buddy Pythagoras stated that A squared plus B squared equals C squared. Very cool visual proofs of that out there if you want to see why this works. And this is just one of those formulas in math that never goes away. You will be using this in Calculus 3 and in calc-based physics and beyond. It pops up everywhere. Okay, so to put that in, plain terms, the square of the hypotenuse, so the length of the hypotenuse squared, is the sum of the squares of the other two sides. Okay, A squared plus B squared equals C squared. I could maybe ask you to memorize that because that's just, it's hard to forget once you know it, Okay, so let's do kind of a gnarly problem involving this. So your TV at home, if it's a 30-inch TV, now this is kind of a small TV, but yeah, the bigger the TV gets, the harder the problem got. So that actually means the diagonal. So does that make sense? I'll try to do it on the screen here. That diagonal, right, is 30 inches. So now you know. So we have a 30-inch TV. And the TV is 6 inches wider than it is tall. What are the dimensions? Okay, so it seems like we don't have a ton of information here. We don't have anything about the area or anything, but we know something about the diagonal. So it's hard to visualize, so what am I about to say? Draw a picture. All right, so here's my TV. First thing we were told is that this measure is 30 inches. Small. And the only other thing we know is that it's 6 inches wider than it is tall. So for the height, I'm going to call the height x because we have enough going on without wondering, like using different variables. Let's keep it simple. So the thing that we're looking for is x. And we know that it's 6 inches wider than it is tall. So if that's x over there, what's that? X plus 6. Right, so even though it's really a rectangle problem, now you see why I just busted out the Pythagorean theorem. It actually is, it's a triangle problem. This is a right triangle, and we have the hypotenuse, and we have some relation between the two legs, so now we can set up an equation. X squared plus x plus 6, quantity squared, is 30 squared. See it? So we're going to get it by using the Pythagorean theorem on this right triangle. Picture's about to go away. All right, so it's important that it's x plus 6 quantity squared. When I say quantity, I mean in parentheses. Right, the one side is x, so you square that. The other side is x plus 6, you square that, and that gives you the square of the hypotenuse. Okay, and that's a quadratic equation, right? It doesn't look right yet, but it is. So clean it up. So the first thing we should probably do is actually square out x plus 6. So remember, x plus 6 squared is actually x plus 6 times x plus 6. So you FOIL it with itself. It's x squared plus 12x plus 36. And then 30 squared is 900. There you go. So we have x squared plus 12x plus 6 equals 900. So start consolidating terms on one side. It's going to be 2x squared plus 12x plus 36. And then we're going to subtract the 900 from that side. 2x squared plus 12x plus 36 minus 900 equals 0. Do the 36 minus the 900. 2x squared plus 12x minus 864 equals 0. Divide everything by 2, right? So that's very important. If you started trying to factor now, you could technically do it, but it would be hard. It's even going to be hard when we do it anyways, okay? So always look for a common factor. And it's nice when every number is even, because right away you're like, every even number has a multiple of 2. So divide everything by 2. Okay, so we just straight up divided both sides of that equation by 2. The way we've kind of talked about in the past is that you factor a 2 out of the left-hand side, but really it's fine to do it this way because 0 divided by 2 is 0. So obviously you have to be careful. 2 divided by 0 is undefined. But the nice thing about having an equation set equal to 0 is you can divide both sides by any constant you want, any factor you want. So you notice the common factor of 2, just take it out of both sides. That will not affect the solution. Okay, so this next part is the worst part because now you have to come up with 2 factors of 432 that are 6 apart. So 432 has a lot of factors. So there's 2 ways to do this. You can make an exhaustive list and just start writing down all the pairs of factors of 432. I think I'm going to do that. Or you could just grab your calculator and start guessing. Just start guessing factors of 432 till you find ones that are 6 apart. So just start dividing it by stuff. Since, you know, this is, I want us to be a little bit rigorous here, let's just do it this way, just so you can see how the process. Okay, so we're looking for factors of 432 that are 6 apart. Obviously, that ain't it. 2 and 216, nope, that won't do it. It's not divisible by 3, it is divisible by 4. So this is the part where you can just grab a calculator and say, okay, 432 divided by 4 is 108. Sorry, 108. Okay, it's not divisible by 6. It is divisible by 8. 432 divided by 8 is 54. Not there yet. It is divisible by 12. 432 divided by 12. I am cheating with the calculator right now. Is 36. We're closer. 432 is divisible by 16. 432 divisible by 16. Again, I'm not doing this in my head. I have a calculator. Is 27. Are 16 and 27 6 apart? No. I think it's also divisible by 18. That makes sense. Yeah, that makes sense. Oh, so it actually would have been divisible by 3 as well. Oh, well, we skipped one. Well, it wouldn't work. 432 divided by 18 is 24. And then you say, wait a minute, stop. I'm done, right? Okay, so I probably will try not to put one like this on a test. But sometimes you get these big numbers that have a ton of factors, and there's really no quicker way to do it than just mash a bunch of buttons until you get the right thing, okay? So 432 is 18 times 24. And so it's going to factor to plus 24 and then minus 18. Okay, so again, we get 2 solutions. Let's look at them. I kind of skipped the little solvey part because we're pretty good at that. So you have to be careful. When you skip that step, I do see people say, okay, x is 24 or 18. It's actually the opposite of that because for like x minus 18 to be 0, then x has to be 18. Okay. So let's remember what the heck x was again. It was the height of our TV. And it can't be negative 24. So generally with these, as you can see, dimensions in like geometry and time and stuff, the negative number doesn't make sense. Obviously, there are problems in mathematics where a negative answer does make sense, but it's not this one. So it's 18. Yeah, the general word for that is an extraneous solution. You'll see that in many, many, many different contexts where you get a solution that seems right. You know, you did all the math right, but one of your solutions you just got to toss out. So let's draw the picture again. This was 30, this was 18. And what do we say? The width was 6, it was 6 inches wider than it is tall. So there you go. That turns out actually to be 24. So just, well, sort of a coincidence that that we got negative 24 for an answer. This is just, my God, okay. That's 24. Okay. So we were asked for the dimensions, and they are 18 by 24. So go ahead and use your calculator and check that 18 squared plus 24 squared is 30 squared. It is. That's called a Pythagorean triple. You'll see more of that kind of stuff in trig class. Okay, and the width is 24 inches. Okay, and that completes chapter 6, and that pretty much wraps it up for Math 1100. So we'll do a little bonus material after this, and that'll be on the final, but, well, we'll see. Okay, so thank you for tuning in.